Triple your pattern making in 3 easy steps. Step 1 is scan, step 2, convert to CAD, and step 3, flatten 3D to 2D. This is ExactFlat, scan to pattern, and we'll show you how. Hello and welcome everyone. This is part 3 in our series for how to triple your pattern making in 3 easy steps. This is the chair that we had first scanned in video number 1, and then we processed and converted that scan to 3D CAD in video number 2. And here we're going to process this into flat patterns. Our first step in the process is to select the chair and explode the mesh. So there the mesh is exploded into its individual elements. And you can remember these are the elements that were defined in the convert to CAD process as part of the peel to CAD software. The next thing we do after we explode the mesh is we're going to weld the vertices together. And this is just a preparation step to begin the flattening process. So we exploded, and now step 2, we're just going to type in here, weld vertices. There we go. And select the part and then hit enter, and there it is done. The vertices are welded. Now we start in the ExactFlat process. The first thing we're going to do is we're going to create an optimal mesh for flattening. The mesh is a representation of the 3D object, and we want the mesh to be in a certain way such that it can flatten easily and accurately. So we use our adaptive remesher tool. The adaptive remesher tool is going to redraw this mesh where it's going to put more denser mesh elements near areas of high curvature and bigger polygons in areas that are more planar. And you can see that here we've just done that, and it just takes a few seconds really to do it. Next, we're going to go into our ExactFlat tools. The first part of our process is to just flatten. So we select the part and we hit the enter button, and you can see there it's flattened. We're going to now just manage our workspace here. There's our flat pattern pieces there, and we don't need to see the 3D object anymore. So we're just going to turn those layers off and just activate the flat layer. And we're going to change our view from perspective to top down. And let's just zoom to extend. There's our pattern pieces. These are the initial unoptimized pattern pieces, and you will see some flaws in these pattern pieces, expectedly so. And here we go to our strain view, and the strain view essentially gives you a strain map. And you see as you zoom in here, these little hash marks here are what we call flip triangles from a mathematical perspective, but what they represent is folds or wrinkles. And here we've selected our pelt tool, and the pelt tool is just going to relax these patterns and prepare them for, again, more optimal flattening. So you can see already we're taking some of that strain out of the part. Next, we're going to use our fracture tool here. And the fracture tool is like a nice smoothing algorithm. You can see that it starts the smoothing process on the location from which we clicked. And once you click it, basically, it's like spreading your hands over the pattern pieces, what pattern makers do all the time. Now we have nice de-wrinkled and smoothed patterns for optimization. These are still not yet the optimized patterns. We're going to go to the next part, which is our optimizer. The optimizer will take into account the warp, weft, Young's modulus, Poisson ratio, and a number of other engineering characteristics. Here we select our material, and we're just gonna, we have a number of materials in the database, but we'll just stick with a cotton here for the purposes of this example. And we begin the optimizer. Now, the optimizer is going to run through these algorithms, and it's going to try and do a couple of things. First, it is searching for areas of strain and sag. Areas of strain and sag are represented by colors. There's not much strain in these pattern pieces anymore. We managed to remove most of it in the pre-flattening stage. Those would be areas of red and yellow, and that really represents elongation of the material, or areas where the material will need to be elongated or stretched in order to fit properly. Now, you don't really want your pattern pieces to have a lot of strain unless it is deliberately engineered to do so. What we prefer, though, is we prefer pattern pieces that really fit perfectly, and they are designed in such a way that the patterns have zero strain. So our algorithms really are running through this process and searching for areas of strain and sag and eliminating them, reorienting our polygonal mesh in such a way that the strain and sag is reduced or eliminated, and maintaining the pattern boundaries. And this is what makes ExactFlat so accurate and so reliable. While other software in the market claims to have pattern flattening, it's problematic in that it works sometimes and it doesn't work other times. But as a manufacturer and a designer and a product developer, you know that if it doesn't work reliably, you have to check it every single time. And that introduces places in your workflow where you're going to slow down. With ExactFlat, you can have full confidence that the patterns are going to fit perfectly. And that's because we have worked and worked and worked on these algorithms, and we still continue to work on them to this day, to be more accurate and to do a couple of things. One, work on any type of material. Two, work on any type of geometry. And three, work on any type of product application. So we believe that we're at a position now in the maturity of this product where we can fully and confidently say that these are the best patterns you're going to get, even if you're doing these manually. There are ways to introduce strain here. We have algorithms for local target strain and global target strain. But we're not going to talk about those right now because that's not really relevant for this particular part. As you can see, the optimizer runs through each piece individually. And on a part like this, it'll take a couple of minutes. Go grab a coffee, some M&Ms or something, and it'll be done before you're finished. And here we are just about done at 100%, and there we are finishing off. So now that we have our optimized flat patterns, we're just going to arrange these for the next part. And there's a couple of tools that we have to make the next part of pattern development easily, but you don't necessarily have to use ExactFlat for this. If you have other workflow tools already in place, then that's perfectly fine. So we're just going to arrange these, and we have a find tool where we can just start with one edge. Here's our find tool. It's the binoculars. So we just click an edge, and it will automatically find the neighboring edge. So you don't have to go chasing your pattern pieces around and figuring out what goes with what. You can simply start with one piece and then click the find tool, and it will automatically find the neighboring edge and orient it right beside it. Now the offset there, those are settings you can adjust. So here we go. We're going to find the rest of these pieces. Click the find tool, and you can see just one click and it'll arrange the pieces. Now you could actually walk the pattern by clicking and holding, and that little hash mark there, you would be able to orient the patterns in a way which is at a right angle to the actual edge that you clicked on. So you see how these edges have curvature. If you want it to be at a right angle to a certain part on that curve, then it's possible to do so. And you can adjust the offset. But here we go, just arranging these. It's pretty easy to do. And you see when you click on a different spot, it just, again, it depends on the curvature, but it'll orient these things. We're not going to do it perfectly right now, and maybe you will or maybe you won't do it in such a way that it's lined up to your satisfaction. After this, you'll be sending this to a cutter, and likely there'll be cutter software, or if you're going to plot it out, you may want to take a little bit more care in doing this. But for our purposes here, it's not that necessary. So as we zoom to extend here, now we're just going to show you some of the very simple time-saving tools, and the first one we have is notching. So I'm just going to move these pattern pieces out a little bit just so that you can clearly see the notching process. Yeah, just move that one. Okay, here we go. So we use our notch tool, and we're going to add notches. Now you see that when you click on one edge, it finds the notch location on the other edge automatically. This is a very unique feature to ExactFlat, and the reason this is so easy and so simple is because we maintain the associativity between 3D and 2D. Recall that our algorithms were drawing the pattern pieces as we go through the flattening process, so all the locations are maintained. And you can apply notches very simply and very easily. And if you're using a different pattern making software, if that's what your established workflow is, these notches will come in and you can easily use them for reference locations. Now we're just going to talk about some of the options we have here. So for example, if In our DXF export, we could put a seam allowance in, and it's not necessary. Again, if you're using another third-party tool for 2D CAD, you can maintain it, or you could put your seam allowance here very quickly. So we're going to put a 6mm seam. That'll be a global seam allowance on this whole pattern piece. And this is perfect for prototyping or for product development. You can essentially have your product patterns ready in minutes in your prototyping studio, and it doesn't have to take days or weeks to do this. And therefore, you can go through many, many, many more iterations. And here we're just going to save this file as a DXF. These are cut-ready DXFs. We have profiles for all of the leading cutting tables out there, so need not worry about compatibility. We have tested this on a variety of different platforms, and ExactFlat works very reliably on all those platforms. Okay, so what we've done is we've exported our file and brought it back in, and you can see that a grain line was automatically applied. There's our notches on the left and right, and there's our seam allowance. The actual cut line is in red and the actual pattern line is in blue. And that's it. That's how you flatten from 3D to 2D. This concludes part 3 on how to flatten from 3D to 2D. It is the last section for this part, and we hope you found the content useful. If you want more, there are other videos on other parts in our series on how to triple your pattern making in 3 easy steps using ExactFlat Scan to Pattern. It's the faster, better, cheaper, and easier way to create patterns for all your products. You can also contact us at your convenience for a demo or to learn more. We'll show you how.